Hi everyone, welcome to Linear Model with me, Sarini Abdullah. For this session, we will learn about some limitations when we are using stepwise procedure in variable selection method. So just a quick recall on the problem on variable selection. That is, if we are given a set of predictor variables to model the response variable y, then the question is that do we really need to put all the covariates in the model or not? So if we don't have to need all the covariates, then how can we select a subset of variables, let's say k-based predictors for the response variable y? And then we learned in the previous videos that stepwise procedure gives us kind of like a good result in selecting the best k predictors under a certain mechanism. But now what we are looking for is that, okay, we learned about the good things about stepwise procedure in the previous videos, but now we will look at some of its limitations so that we are able to be more careful when we have to apply the stepwise procedure. So first one is that there are too many individuality tests in doing the stepwise procedure. And because of lots and lots of individuality tests, it results in an inflated alpha, where alpha in this case is the type 1 error. Let's have a look in more detail about what we mean by the inflated alpha. So when testing the hypothesis, let's say here the null hypothesis is the one that we are testing. So the condition of that hypothesis, there are only two possibilities. That is either it is true or it is false. And then let's say we have actually the null hypothesis is true, and then our decision is not rejecting the null hypothesis. Of course, this is a correct decision. But just in case that we reject that hypothesis, it means that we are rejecting something that is true. It means that we are making an incorrect decision. And then the probability of making that incorrect decision is measured by alpha. So this alpha is called the type 1 error. That is our concern in this session. On the other thing, there is a possibility that the null hypothesis is in fact false. And then in that case, rejecting something false is, of course, a good decision, a correct decision. And the probability of making a correct decision is measured by 1 minus beta when the condition is false of the null hypothesis. But then if we are not rejecting it, it means that we don't reject something that is false, there's something wrong with that, and that probability of making that mistake is measured by beta. In here, beta is called the type 2 error. So this is type 2, alpha is the type 1 error. That the one that's for our concern is that alpha. Now let us see why repeated t-tests will make the alpha becomes inflated. Let's say we just have one t-test, that is the null hypothesis, for example, testing whether beta 1 equals 0 against the alternative that beta 1 is not 0. So then we said usually by default, although not always, but usually we take alpha is 0.05, meaning that the maximum tolerance for us to make the maximum tolerance of us to make a mistake that is not rejecting, that is rejecting something true is just 5%. That is why we said alpha equals 0.05. But then let's say we have two t-tests, okay? So we are testing whether beta 1 equals 0 or not. This is actually by, we want to see whether, for example, x1 is a good predictor to be included in the model. And then let's say for this hypothesis, we want to test whether x2 is a good predictor to be included in the model. And we do the test separately, one test for each of the beta parameter. So in case we have only two predictors, then the probability of rejecting at least once of the null hypothesis, the correct null hypothesis, that is the type 1 error, is given by, we use the complement properties in here. So it is equal to 1 minus not rejecting the null hypothesis at all, given both null hypotheses are correct. And then using some mathematical manipulation, we get this relationship, and then we get it that the alpha, that the probability of making a mistake, that is rejecting at least one beta, when in fact, the probability of rejecting the null hypothesis at least once, when in fact those null hypotheses are correct, is 0.097, which is greater than the setup alpha here that we set to be 0.05. The same thing, the same procedure applies. Let's say here we did some simulation. Let's say if we have two predictors, if we have three predictors, if we have four predictors to be considered whether they should be included in the model or not. And here we calculated the type 1 error by doing, for example, like for predictors, it means that we are doing 4 t-tests separately. And then we can see here that, let's say we have 14 predictors, and then in the first procedure of the stepwise procedure, we do 14 separate t-tests, and in that case, the type 1 error is no longer 0.05, it's inflated up to more than 50%. So in general here, we see that the probability of rejecting the null hypothesis at least once, when in fact all of those null hypotheses are correct, is given by this formula. And that depends on how many t-tests that we are running here. Let's say k, then we can calculate the type 1 error. So that's the first problem with the stepwise procedure. The second problem is that in stepwise procedure, it only considers a linear relationship between the x and the y and the response variable here, while actually, in fact, there is a possibility that many other functional forms might take in the relationship between x and y, and those kind of relationships are ignored when we are doing the stepwise procedure, which is not really good, because we actually want to include the variable with its proper functional form, incorporating the relationship between each predictor to the response variable y. And the third problem with the stepwise procedure is the blind selection. Blind selection means that, okay, we treat all the predictor variables equal, so there is no preference of one variable over another. It just really depends on the t-test, while probably if we have a little bit knowledge or understanding about the context of the problem, we can incorporate some variables more appropriately in the model. So here are at least 3 problems that we need to be aware of when we are applying stepwise procedure in the process of variable selection. when we fit the multiple regression model. So in conclusion, we can say that stepwise procedure can be seen as a rough way of selecting predictors. However, due to some of its limitations, a better model could be achieved by incorporating domain knowledge or our understanding about the problem in the model building process to get a more improved, a better model that fits the data.